is the first structured data type that we use. And there's a couple of terms we're going to use here. Array is the variables. There's no keyword in C++ that's called array. We're going to actually use square brackets to give a size of an array. So there's no keyword that says array. So we're going to declare an array, and the array is going to be made up of two things. The array is going to be made up of elements or members of the array, and we're going to use something called an index to determine which element of the array that we're accessing. So these are the terms we're going to use: array, element, and index. And none of these are keywords in C++. Okay? So the format is the following: type, which we know what a type is, what our types are: int, float, char, bool, string. Okay? A name, which we're going to give to the array, and then we're going to use square brackets, and we're going to specify a size. And this is going to allocate space in memory for the array. Notice the word array never appears here. Okay? So I only have to do this once. Now, something to remember about the size, and this is true in C++, the size must be a constant. What do I mean when I say the size must be a constant? Give me an example of a constant. A fixed number, such as 100, right? Or what's the other way of doing a constant? Declare a constant. But it can't be a variable. Either a set number, like 100 or 1,000, okay? Or a constant that I've already declared. I cannot make a variable, an array of a variable size, because when the array is declared, the same thing that happens when a variable is declared. What happens when a variable is declared? Space is allocated in memory. When an array is declared, space is allocated in memory. So the size must be known. Does that make sense? Okay? I'll go over this again. So here's an example of declaring an array of test scores and allocating space for how many of them? 30. So float test scores sub 30 means in memory space will be allocated for 30 of those suckers. Okay? So that statement allocates space for all the guys. I could have made a constant and then replace, whatever. It doesn't have to be a 30 there. I could use it. That's oftentimes done when you declare arrays. So therefore, if you want to change it later, you can change it in that one location. But the bottom line is whatever's in those brackets, those square brackets, must be a known value. It can't be an X or a variable. Okay? Okay, so that's easy, right? So we can declare an array called days of type float with 365 of the suckers. We can declare an array called code, which has 12 characters in it. We can declare an array called buff, which has 100 integers. What do these guys look like in memory? Okay? So if I declare an array called test scores, type, name, size, that's all you have to remember, type, name, size, what takes place in memory is 10 of these guys are allocated. Each one of these guys is called a member or element of the array. Now, notice that what we've done, though, that we're going to use a number to access each element of the array. And we're going to call that an index or a subscript. Either one, they're interchangeable. Okay? So since I've allocated space for 10, what do you notice about the highest subscript that I can go to? And why is that? Why is it 9? Because I start with 0, that means that 10 elements is 0 through 9. And welcome to coding. Coding is almost always 0-based. Bless you. Coding is almost always 0-based. So this is a 0-based array. The first index is 0, and the last one is 9. That doesn't mean you give 9 as your size. Your size is still 10. Okay, does that make sense? Your size is still 10. So 10 elements means elements from 0 to 9. You with me? Okay, cool.